Hi, everybody. This is Channing Dutton, and we have a great show for you today on the 3 Degrees podcast with my co host, Chris Gloninger and David Thorson, especially for those of you in central Iowa and KCCI viewing territory. There's going to be a fun event here this Tuesday at Drake University, and Chris is going to be explaining that and introducing our guest. But I do want to remind you all you can get this podcast on Substack, Spotify, or on YouTube. And when you're there, give us a follow, subscribe, and best of all, write a review, because people need to know that we are talking about the issues that are just beyond the horizon, the things that are going to happen tomorrow. And so spread the word to people who share that concern. Chris?
Thanks, Channing. Yeah, so I will be one of the keynotes at the Iowa Environmental Council's annual conference. I'm excited about that. One of two talks I'm giving, the next one later in the evening at Urbandale Library, and we're talking about climate change with a book of fiction, but really the underlying theme is far from fiction. It's based in climate reality, and it really is a well-done book. So that's in the evening, but then during the day is the Iowa Environmental Council's conference. It's only $50 to go, and there's still time to sign up if you are watching this podcast ahead of Tuesday's event. They came with this request. They wanted me to talk a little bit about climate change and the nexus of health, climate, and water. And really, they're all tied together. And what's funny is when I looked at the data for the first time, when I moved to the state, I noticed that there weren't the trends that we were seeing, say, in New England, for example. Warming wasn't as apparent if you look at the long-term averages. And it's what's known as a warming hole. So there's warming, but it's not to the rate that we're seeing across other parts of the country, other parts of the world. And a lot of times climate skeptics in their spewing of misinformation and disinformation will show random data points from Iowa, from northern Missouri, from eastern Nebraska that show this subtle warming, whereas it's a lot more significant elsewhere. There was another one of these across the southeast, down towards Georgia, and that has actually not been the case in recent years. It's less apparent, but today's guest is really going to shed light on why this phenomenon happens, why we see less warming in this part of the country. So it's Dr. Jean Takle, Iowa State University. Dr. Takle, you've spent a lot of time researching this, and just dive in with the idea of a warming hole. We're still seeing warming, so we're not seeing warming, but it certainly is at less of a rate than other parts of the country. Why is that?
In about 2002, when we were doing regional climate modeling for the U.S. and for a doubling of carbon dioxide, and PhD student Zaital Pan came with this data that showed that with a future scenario that the maximum temperatures were actually not going to rise very much in the middle part of the country. That it was not a cooling because it was rising slightly. And so I said, well, Zaital, we have to really call that a warming hole then. It's a hole in the warming. It isn't the cooling. And so he said, yeah, that's what it is. So that's where it all started. And of course, being a first evidence of that, we were pretty skeptical about that. It didn't seem, really plausible. We couldn't understand from the, just looking at it what was going on. But when we started to dig deeper, we found that in fact there is a good physical cause for that, and it's related to global warming. And so it's related to global warming, but on a regional scale, in this particular part of the country, central part of the U.S., we're actually seeing a hole in the warming, or almost a cooling. And so and when we look at maximum summertime temperatures, some that are of key importance, of course, to agriculture and human health and water resources and so on. So that's where it all started. So we had to dig into this then and try to find out what in our model was doing that it should give us this kind of behavior. So when we looked, we found that there were a few elements of the atmosphere that were behaving quite differently than under the normal current day climate scenario. The first was that, of course, we know that the global oceans are warming, and that includes the Gulf of Mexico. So we saw that if we warm up the Gulf of Mexico, you will create a dome of increased moisture. You'll get more evaporation over the Gulf, so you get this large dome of moisture. Then the second item we found was that a high pressure center develops over the eastern U.S. and this is natural. They call it the Bermuda High. It's been called that for decades. And of course, there's a low pressure center over the Rocky Mountains. So that combination of high to the east and low to the west sets up a circulation that brings a southerly jet, or the Great Plains low-level jet, which flows from south to north into the Midwest. And this low-level jet is one that intensifies at night. When the sun goes down, it reduces the friction between the atmosphere and the land surface, and so the flow actually accelerates and brings then this excess moisture up out of the Gulf of Mexico and shoots it right into the Midwest in the early evening and on toward midnight. And that's why we have and this particularly is in the April, May, June period, the late spring and early summer. And it shoots this warm moisture into the Midwest and fuels then the normal thunderstorm behavior. We call them mesoscale convective systems, but it fuels these large storms, which then lead to these very intense rain events that occur under these conditions. So that's where it all started with our being able to model that with the regional climate model.
Thank you so much, Gene, for that. I'd like to welcome any YouTube viewers really to dive into the graphics and really explore these issues with us here. It's really important. I spent so much time talking with Gene over the years. I don't know how long I've known Gene, but I've known about him for a long time. And we've talked about the Goldilocks climate that Iowa has had that is relatively perfect for growing crops here in this in the state. And of course, that's what we're known for here in Iowa. And I know things are changing. Gene's been involved in a lot of the Iowa climate statements that have been produced over the years with all the scientists that are thinking about climate and teaching about climate in the state. I'm wondering if you can go into how agriculture is being affected by the changes that we're experiencing in this Goldilocks climate that you discuss, and really kind of what that means for viewers that don't really understand it.
Well, it's been known, farmers, of course, I grew up on a farm, so I understand how farmers feel about climate, and it's always a little bit of walking on eggshells each year to know, is this going to be the drought year? Is this going to be, are we going to get the corn planted in time, or is it going to be delayed? These are all questions that they not only are curious about, but they have to make decisions. They have to buy seed corn in maybe in February. And so they have to kind of think, do I want long season or short season seed corn? And so it becomes a very important economic decision as well as curiosity. So the long and the short is that the growing season is longer now than it was when I grew up on the farm and a lot of years ago. And so that's good for agriculture. A longer growing season means that you can plant longer season hybrids, you get better yields. However, these heavy rains that I mentioned in the April, May, June period also lead to flooding and a shorter window of opportunity for getting the crops in. Well, the machinery companies have responded to that by building bigger planters and faster tractors that can pull these big planters, and they can now plant a football field in about 26 seconds. So they've met the challenge in that area, and but it's come at some cost, of course. It's also brought more favorable and rain reservoir, the rain, these heavy rains. We have these deep water holding soils that in the Midwest that catch this spring and summer, early summer rain and hold it at 3 to 5 feet, and corn roots down below 5 feet, down as far as 12 feet into the soil in July and August then, and pull that out. And so it really, climate change has really helped crops in many ways. But it also then, as I mentioned, it may delay the planting, and the summertime temperatures are very important too, because these occur during the pollination period. And the pollination period, of course, is very critical. It's a week-long period or so on, but farmers can plant different hybrids and spread that time out, because so that they can not put all their eggs in one narrow pollination window, but spread it out a bit and spread their risk. So it becomes a very delicate balance then for farmers to work with the climate that's being presented and try to figure out how they can cope.
Gene, I feel like the student, but the graphic that we've been showing during especially your opening comments, I really would urge our viewers who are just listening to this podcast to jump into our YouTube live channel where we are broadcasting this, and you can actually see the image. But I just want to make sure I understand the basic elements of this 4-part diagram. We have a warmer Gulf of Mexico with increased humidity.
Right.
And then we have has climate change affected the strength or the rigidity of these pressure systems, both in the Rockies and the eastern U.S.?
Yes, as those become intensified, then that has the effect of accelerating the northward flowing winds that are associated with this orientation of pressure gradients.
And in our graphic, Gene, the arrow that you have that people look at, is that representing the movement of the humidity?
Yes. Yeah. Just that's the long and the short of it. Yes.
And then, so climate change has brought us more moisture. Are we seeing that in the precipitation patterns here in the zone of the warming hole?
Yes, we've looked at that 3-month period, April, May, June, and during the 20th century, the 3-month total over 100 years was 11.4 inches. But during the last 20 years, from 2000 to 2020, that's gone up to 13.8. So that's 2.4 inches of excess rainfall. That's average over the state. Now, that's about 2 cubic miles of water in any given year. 2 cubic miles. That's enough to fill Red Rock Reservoir 74 times. It's enough Lake Powell from nothing to its current capacity. So that's an enormous amount of water.
Hey, Gene, we just had a little glitch. I want to make sure the audience hears that. Give us the comparison about the Iowa lakes and Lake Powell. How much water is that? Is the increase?
The increase, just the increase from the 20th century, is about 2 cubic miles. And so you can do the math. It's a 5th grade arithmetic math problem. Just look up the volume of Red Rock Reservoir and see how many times it could 2 cubic miles could fill that reservoir, and it comes out to about 74 times, I think.
And what would it do to Lake Powell out in
it would be about, I think it would take about 7 years, or maybe even less than that. Just a few years, if that excess water ended up in Lake Powell.
But let me drop one last of these mini questions on you. So we have this warming hole. We're not warming as fast, but we're still warming. What is the projection of what's going to happen next? Is we're just going to have more and more humidity, or is there a change looming that we don't yet understand that the future will see?
Yeah, that's of course a really good question, and a recent paper, 2023, a paper, lead author was Eichscheid, who raised the question, why has the warming hole not disappeared? And so, and this was a group of leading climate scientists from across the U.S. Who looked into what other factors there might be. And so there are other factors of aerosols that are sort of cooling the climate a little bit, but the number of pollutant aerosols is going down. So that would suggest that that's not leading to an increase in the cooling. But there are what we call internal variability factors in the climate system. That is, the global climate changes, but there are regional differences. There are some regions that are much hotter than normal, others that are much cooler than normal. And we happen to be one where one of these cooling regions happens now to be anchored over the central US. The question is, will it stay? Well, it does depend clearly on the alignment of the low-level jet with the where the warm and moist air is over the Gulf. And in some years, that is not aligned quite right. And so we may not get a cooling or lack of warming in Iowa, but they may get it in Ohio, for instance, or Kentucky. So it's not, we can't say with high certainty that this will continue or intensify, but it's very likely that it will not go away. And so it will continue to be a contributing factor well into mid-century and beyond.
You know, Gene, people do show, this is actually going to come from my presentation on Tuesday, but Climate Central defines an extremely hot day above 85 degrees in Mason City. And if you look at the trend, there's 7 less days. So it's just for people to understand what we're talking about in another visual sense. But then if you look at the average temperature of Mason City over the course of the year, you can see that upward trend is still quite apparent since records began in the late 1940s. Now, all of this data helps us determine trends. How concerned are you about what is happening at the federal level? I know that there's a group of scientists that have started climate.us, which is their effort to kind of keep some of this climate data around and available to the public. Are you concerned about what cuts are to come?
This is very concerning because we need data. We need satellite data. We need observations, surface observations. We need balloon launches. We're still launching balloons twice a day at many locations around the U.S. These are critical because we need, as is apparent with the low-level jet, we have to get measurements at a vertical profile of measurements, so we can see that yes, there is in fact a jet establishing, and it establishes not only for 36 hours at a time. It comes in episodically. It'll come in for a period of 6 to 8 hours, and then it diminishes. We have both the time and spatial resolution with these observations so that we can understand these changes. We can and then be able to predict them, so we can use these models then for developing better climate simulations for agriculture, for human health, for water resources management, for community resilience. Many of these really rely on very accurate data.
Mm-hmm.
One of the things we've talked about a few times over the years, there's a lot of people discussing how agriculture can be a part of helping curb climate change using different methods. One of them has been soil carbon sequestration, But I'm wondering if you could talk about the problems associated with that in Iowa, because our soils are already pretty rich and saturated with carbon. Could you explain to the public a little bit about this concept and maybe some of the things that we can do here in Iowa with agriculture to help?
Yes, of course, agriculture is a management of carbon in the broad sense. And some interesting things about soil carbon is that there are two kinds. We can think about it as two kinds. One is what we call recalcitrant carbon, which is carbon that doesn't break down. It doesn't oxidize and become carbon dioxide and go back into the atmosphere. Most of this carbon that we have in our Iowa soils now is the recalcitrant type, because it was formed over the thousands of years when the prairie fires were a common feature over the Great Plains and into the Midwest. And that process turns carbon into if it doesn't burn completely, it forms this recalcitrant carbon. And so it'll last for thousands of years. The other kind that if you plow your corn stalks or put your corn stalks under the soil, most of that decays and goes back into the atmosphere as carbon dioxide within a couple of years. So we've actually reduced our carbon content of the soils. Agriculture has actually reduced the carbon by about 50% since we've been tilling the soil in the Midwest. So we've reduced the carbon content. One of the good new factors is that deep carbon, when it's put down by plant roots, it will be the oxidation, the formation of carbon dioxide will be suppressed if the groundwater table is rising. That is, carbon dioxide can't be formed in saturated soils. So if the soils are saturated more, that means less carbon is being oxidized. So that's a good thing about the increases in rainfall that we have. And farmers work with this process. If they use minimum tillage, if they try to reduce the amount of overturning of the soil during the normal annual agricultural processes, they can actually increase the amount of soil carbon that's being stored. So yes, there are ways that agriculturists can work with this and improve our soils.
Gene, let me follow up about this concept of the warming hole. I think what you said in the previous segment is, this all depends on the amount of moisture in the Gulf. It depends on the action of the low pressure and high pressure systems and how they interact with each other. And so there's no guarantee that next summer we're going to have the high humidity, high precipitation event. If we don't have that, if it moves to Kentucky, what will we have here in Iowa?
Iowa sits at kind of the break point between the very dry part of the country in the west and the more moist part in the east. So that boundary can wander forth and back to the east and back again, and give Nebraska or even North Dakota very heavy rains. And so, and that's kind of the luck of the draw on an annual basis. I can say that there seems to be a tendency for, we know of, we talk about Tornado Alley, and we talk about these intense weather events, these mesoscale events that are Midwest and then kind of turn and toward the Ohio Valley. There's some talk about that whole system shifting a bit to the east, but it's certainly not shown yet in our annual rainfall patterns. We're still increasing our on a long-term basis. We're still increasing our rainfall here in the Midwest, but but variability, and very importantly now, the variability from year to year is going up. And that means that despite the fact we're having more rain, recent studies have shown that the mega drought of the 1930s, 1936, which was, of course, a very, very consequential event, could return about once per decade by end of the century. So these extreme, this is in Iowa. This means that these extreme wet events could be interspersed with these occasional extreme record-breaking dry events as well.
How long will this Goldilocks climate persist for corn? And I know we've talked to people and we're friends with people who are corn geneticists who have been able to kind of adapt that. And this kind of builds on David's question. Is there a time when it's no longer a good agricultural economy in the state of Iowa?
As I pointed out, and of course, the present year, what I'm hearing from my brother who farms in southwestern Minnesota, same thing is happening there. Just great crops. They've had timely rains. They've had they got the corn in early enough, and so there are going to be lots and lots of good years. However, the variability is something that farmers need to deal with. It's always an issue, and the concern might be that there would be some back-to-back sequential years where economically they would be exposed and could yield to, or could really turn into a bad situation. So it's the variability that they're going to have to deal with, and thinking ahead, and that's an actionable fact that they could be thinking about how they could spread their risk. But if the trends do continue, we may have more difficulty with, for instance, getting the crop in. So instead of planting starting in mid to late April, if you start in late May, like we did back in the 50s, you get it's a pretty short season. So if those intense rains do continue, even the faster planters may not be able to cope with it.
Gene, you've been involved with some big national climate assessments and IPCC, even some Nobel Prize work with your own work. And maybe you could tell us a little bit about that, but also how important is it to bring that down to the more local level and maybe have an Iowa State climate assessment so that we have a blueprint for the state of Iowa going forward?
Well, we have a long history of really good, coordinated, collaborative international research on climate. It's been remarkable, the kind of collaboration that exists. I don't know of another field that is so collaborative. And because I could go to Germany and I could talk to one of my colleagues over there and say, hey, could I take the Max Planck model and could I use it for Iowa and run it there and try it and tweak it and play with it a little bit? And sure, go ahead. Yeah, we'd like to see how it comes out. It's very, very collegial. Nobody's territorial about climate information. And so and those are valuable relationships that exist. And the worry that I have is now that there's going to be some disruption of that trust among scientists who have worked together, and they have incrementally improved climate models and studied and been self-critical about how they're working. And certainly we desperately need to continue that if we want to continue to be able to build resilience, human resilience to a changing climate. The global assessment and the two national assessments that I've worked on don't really speak specifically to Iowa. They talk about the Midwest. It breaks it down to regions, the Midwest. But as we know, Iowa is slightly different from Nebraska or Wisconsin. And so we need to look at what's going on in Iowa. And that's why there is a need for a climate assessment for the state of Iowa so that we can, because decisions are made at the state level. Many decisions are made at the state level. So it's the jurisdiction, it's the sweet spot region for making policy that will affect and that we can cope with climate.
Excellent. Dr. Gene Takle, thank you so much for joining us for this edition of 3 Degrees, a podcast. We'll hopefully see you in person, everyone listening or watching, at the Iowa Environmental Council's conference on Tuesday. Tuesday, I believe, is the 16th. So Tuesday the 16th, we hope to see you for that conference. So for Channing Dutton, David Thorson, I'm Chris Gloninger for this edition of 3 Degrees, the podcast. We'll see you next time.